All right, hey there, welcome back to Coding at Home with Code Hub. We've got a couple quick notes today. So we did some coding with for loops yesterday, which hopefully you thought was kind of interesting. It's one of the more exciting things about programming, and I hope to show that to you a little bit later today with one of the playgrounds we'll get into. On that note, we're going to need this playground, this URL. If you could go to that URL on your iPad, the codehub.ie/playgrounds, there's a subscribe button that'll subscribe to the playground feed that I've developed. It's got a list of 4 or 5 playgrounds. There's a text adventure one, there's a couple of turtle graphics ones, and there's a Code Hub Answers one. And we'll be using all of those throughout the course of this Coding at Home program. And then we'll and today specifically, we're going to be working with the Turtle Graphics Simplified playground. And we'll show off how loops can be a lot more interesting than maybe just navigating byte around a particular maze. We're going to build different shapes. We can do a bit of drawing. Hopefully you can play with it in your off time, and we'll see what you come up with. As before, we still have our discussions board and our Google Classroom. If you want to sign up, you can ask questions there, or you can still just shoot me questions through the codehub.ie website. All right, so let's get started. All right, so we'll bring up our book here. All right, so we left off with loops, and we were in chapter 3 of Everyone Can Code Puzzles. We got through all the sessions, right? We did introduction, we did using loops, looping all the sides. We even did to the edge and back. There's a couple other loop jumper and branch out that we can also play around with. So let's take a quick look just to refresh our memory what loops are. Maybe we forgot, we had a big lunch or something and we can't remember what we were doing. So let's open up Playgrounds. There we are. We did to the edge and back. We solved this one yesterday. If you remember, we wrote a little function called go out, toggle, and come back, where we solved one particular piece of the puzzle where we would go out, toggle the switch, and then come back to the center. And we did that 4 different times down here. Then we also showed you how to do it without using our custom function. All right, so let's see. Let's go off to we could do loop jumper. Loop jumper looks a little bit like this. We've got to solve a puzzle. Basically, we've got to start from scratch. So let's have a quick look. That loads. This one might be a little bit tricky to figure out the pattern here. Will we give it a shot? Let's give it a shot. All right. So if we think about this, we've got byte. We want to solve this puzzle, and ideally we'd like to use loops so that we don't have to write too much code. We want to move forward. Let's see. We move over twice and collect gem. That looks like that kind of repeats that pattern. And then does he always move forward afterwards? Yeah, pretty much. So let's try doing that. Let's try creating a new function, and we'll call move and collect. If you look, you'll see that I'm using that same syntax. I use my camel case here where move and collect is a sentence that I could tell to my buddy with the spaces taken out and the first letter of each word, except for the first one, capitalized. So in our function body, all we want to do is move forward twice, move forward again, and then collect the gem. Now, once we do that, we're typically going to be facing this way. We want to turn right and then move forward once more. So let's add that as well. So let's turn right, and then we'll move forward again. Hopefully this is all starting to feel very familiar. So we have our function that we could call from a place like here to go get our gem. So let's see, how do we get to that point though? So let's see, we need to move forward once. If we look at from byte's perspective. Then we need to turn left. And now we're ready to call our function. So let's call our function move and collect. Now let's try running this and see how we get on. So byte's gonna move forward for us while we're thinking about it. Off we go. Move, move, collect, turn right, and move forward. Okay, cool. All right, so we've tested that bit out. Now, if we look here, we could go to this portal, or if I turn, we could actually do our move forward, collect, and then move forward again. And then we wind up here. We move forward twice, and go forward again. Move forward and do it again. Okay, so that's cool. So maybe what we'll do is we'll have byte turn left here. Now, I just was talking through that, and we did it a bunch of times, right? So if he's turned left, byte is going to be facing this way. We're going to call our move and collect again. We've gone through the portal. We're now facing this way. Oh, no, we're facing this way. So we'll want to turn left again and call move and collect. Now we're here because we've moved forward, turn right, move forward, and we're facing this way. We'll have to turn left again. As I'm writing this code down, I'm kind of thinking, do you know what? Maybe I could add some of this code to my function because I'm repeating a lot of this. And maybe because I'm repeating a lot of it, I could put a lot of this into a for loop. So let's try calling move and collect again, and let's see where we are. I don't think this is going to have solved it, but let's check it out. So we're moving forward, turning left. Now we're calling our function move and collect. Collected our gem, turned right, and moved forward. Turn left, gone and collected our gem. Turn right again, move forward, zip through the portal. Calling our function again. Okay, and we're calling our function again. Okay, we need to call it one more time, and we need to turn left, and then if we move forward here, we're going to pop out here, move forward again, and collect the gem. So really, all we need to do is turn left and move and collect. Now, that's going to solve the puzzle, but as we're going to see, if we look at our hint down here, and as you can see, they acknowledge that this is a tougher puzzle. We're getting a bit more advanced now, so the puzzles are going to get tougher, and we're going to have to think back about some of the lessons that we've covered already. So they give us the solution here saying, oh, you need to move forward, turn left, move forward twice, then turn right. So it's a challenge, no provided solution. Let's try running the code that we have here. Now, you'll note that we don't have any loops. We call a function a bunch of times, but we don't have any loops. So there we go. We're through the portal. We're doing our turn left and then move and collect again. And the solution that you come up is going to differ based on just how you think, how you look at this puzzle and say, oh yeah, cool, I can see the pattern here. I can identify it pretty quickly. Through the portal, comes out. All right, and we collected it. Nope, and we almost sent him off the edge. Not great. Okay, we might want to fix that end bit where we move forward at the very end. But let's see. So we have a bunch of code repeated here. So this move forward is not, but turn left, move collect, we call a bunch of times. 2, there's another 2, there's another 2, there's another 2, there's another 2. So 1, 2, 3, 4, 5 of these. So let's try a for loop. So like we just said, we have 5 of them. And then we're going to use our trick where we tap on the brace, the closing brace here, and it turns it all blue. And I'm going to drag down. And I'm just going to drag in 2 of those commands, the 2 that I repeat all the time, into my loop. Now, if I accidentally dragged all the way down and dragged everything in, what do you think is going to happen? Well, it's going to turn left, move and collect. So it's going to go up here and run this collection of commands. It's going to come back down here, turn left, and it's going to go through all these commands, and then it's going to go back to the top and start all over again, and it's going to do it 5 times. So if we run fast, just to have a check and see what it looks like. So we're going to reset. Byte's going to fly through these. Okay, we've collected all the gems. Okay. Collected the gem. Uh-oh, now we've kind of thrown Byte into a little loop. Maybe that we don't want to put him into. Let's stop him. Put Byte out of his misery there. That's not great. So if we delete these, because we solved the puzzle with all of our code inside this for loop. So let's get rid of all of this code. We don't need to do it 5 times. We only need to solve the puzzle once. And I'm just tapping on the function name and then hitting delete when it comes up. Let's try running this one just at faster speed. Let's see it. All right, collect the gem, forward twice, collect the gem again, through the portal, turn left, collect the gem. This is looking good so far. Okay, we still have a little bug where we almost send Byte off the edge at the end, but this is much better. Now we could improve that by saying, well, maybe what we should do is instead of calling this move forward at the end, maybe we needed to somehow put that at the beginning and take this off here. But I'll leave that one up to you. And if you want to post a solution in the homework channel in the discussions forum, I would love to see some of your solutions about how you might fix that without sending Byte off the edge. All right, so that's Loop Jumper. Let's try out, just for kicks, Branch Out. This is another one that's a little bit more obvious what the pattern might be, I think. For me, anyway. So we have this path that we're going to walk down. We need to go down each row and toggle a switch. They're all identical. So immediately I'm thinking, oh great, we've got 3 of these. I need a for loop that's going to do something 3 times. So let's try to solve one of the rows anyway. And we'll call it solve row. All right. So what we'll do for each one of these is we'll assume that Byte is standing at the edge of the row and is facing forward. So the first thing we're going to have him do is turn right. And then how many steps forward do we have to go? 1, 2, 3, 4, 5, 6, 7. Okay. Well, we could put 7 move forwards there. Or actually, this is a pretty good case for creating a loop, right? So let's say for 1 and 7, because we're going to do it 7 times, we're going to move forward. And then when I start typing it, the auto completion shows up, so we'll use that. So we're going to turn right. The next thing we're going to do is loop and go forward 7 times. After that, now this is the code that's going to get executed inside that loop. So what we want to do now is get outside the loop. So once we're done moving 7 times, now we're going to toggle the switch because we're at the end. Then we want to turn around, turn left twice, and we want to get back. Well, we can do another loop to move forward 7 times. All right, we can start typing and move forward. Hide the keyboard. Okay. This is looking pretty good so far. So to solve the row, we're going to turn right at the end here, move forward 7 times, toggle the switch, turn around, and then in a loop, come back 7 times. Not bad. And then at the end of this, maybe this is outside of our function, we'll get back up to here and solve the next row. So let's move outside of our function. So you can see we have a couple of these braces here. So we have, if we tap on this one up here at the end of solve row, it'll select the whole of the function. If we tap on this brace here at the end of this for loop, we're going to see that this is the code that gets executed, that move forward. Now, some of the bugs you're going to see is when you might have your for loop has a few too many things in it. So in addition to moving forward 7 times, every single time it moves forward, it's going to then try to toggle the switch, then it's going to turn left, and then it's going to go back and repeat. So that's not going to be what we want to have happen. So we'll want to drag back and say, okay, the only thing we want to have repeat in there is that move forward command. So let's try getting to the first row and solving that first row anyway. So we're going to move forward twice. And then we're going to call solve row. Let's check it out. All right. Off bike goes to the front of the row, turns left. Now we're in our solve row function. Turns right, rather. It's very important you know your right from your left. All right, we're going to toggle the switch, turn around, and then come back. Down the steps, and then we're back. All right, cool. So then at this stage, we need to turn right again, move forward twice. And in fact, I might even put a little space between these guys so that we know it's a new thing. Solve row, hit return again. At the end of this solve row, we'll be at the end. We'll do the same thing again. And anytime I start thinking, oh, I have to do the same thing again, this is where I start to think, ooh, could I use a loop here? Is there any way I could add this to a function or add this to a loop so that I only have to write it once and then I'll kind of call it from somewhere else? So this will probably, I'm guessing, without running it, solve the puzzle for us. Now, like I said, we have a few things where we repeat. We have our move forward. We have our turn right, move forward twice. We could potentially add that to our function that we then loop over. Will we try it? Let's try it. All right, so we're going to add a loop here. Actually, instead of a function, what we'll do is we'll say, all right, so we want to solve it 3 times. So we'll create a for loop 3 times. We have 3 rows to solve. How do we start it off? Well, the thing that they have in common is that we move forward, and then we solve the row, and then we turn right. Ooh, maybe I need to group these a little bit differently. Maybe I need to group it like this. Does that make more sense? If I add a turn right at the bottom here, we're not sending byte off the edge, so that's not a bad thing. He's just going to turn at the end. Maybe that's what we do. Maybe we're going to tap on our closing brace there and drag it down to extend it over here. We're going to clean up this code because we don't want this code to run because this will do the job for us. We're going to delete that. Delete that. I understand watching someone delete code is a little bit like watching paint dry. But trust me, you'll appreciate this when you become a professional programmer. That deleting code is one of the nicest things you can see. So let's try running this. And in fact, we're going to step through it just so we can see what's happening when we run this code. So you'll remember before when we've written code, these functions, they don't get run right away. We have to actually write code down here. The func keyword is just telling Swift that, hey, remember this for later. I'm going to call solve row, and these are the set of commands that I want you to run when I get in there. Down here, we have a for loop. When we get to the for loop, Swift says, oh, okay, cool. This is going to be something that I have to repeat over a certain number of times. So this code will get executed right away. So we're inside the function. We're repeating ourselves 7 times moving forward. And another thing I might do with this particular set of code, as I'm taking a look at it and going, how could I improve this? What could I do maybe better so I'm not repeating myself as much? I might go in here and say, do you know what? I do this twice. I do this for I in 1 ... 7, and for I in 1 ... 7 move forward. It's the same in both places. I might actually turn that into a function to say move forward 7. And have this code live inside there. That might be something that you do. So far, we're looking good. We're on our second pass of our solve row. We're coming back. We're in this loop down here. And we've got one more to go. So we've hopped out. We're in this last. We're doing it the 3rd time. We're calling solve row. So up we go 7 times. Nearly there. I think Byte's getting a little bit tired. There we go. Coming back down. We're in the home stretch. We're in this last loop here. Move forward. We've only got a couple more to go. Excellent. Great. We've gotten Byte to the end. We had a little turn right at the end that we didn't need to do, but it's fine. We solved the puzzle and everything looks great. These are worth going over and trying to solve them in different ways. Even though we get a little great job at the end here, we can hit the X button and keep changing our code and rewriting our code to see how else we could solve this particular problem. Now that's all fine. And we've done pretty well. There's a few other gem farm and 4-stash sweep, which would be fun to work through. I'm not going to work through them here live with you because what I want to do is show you another way that we can use loops. It's fun solving these puzzles and everything, but it's not for everybody, right? So we have a set of puzzles here that looks like there's a pattern again. You know, we've got to toggle switches. We've got to collect 2 gems. That's worth your while to go through. 4-stash sweep is another one where we have to find the pattern. Now, you can brute force it and just write all the code that will go and collect all the gems and toggle the switches. I'd really love it if you could try using for loops and functions that we've been working through the last couple lessons. Again, here's another slightly more abstract because you have to think about where you're going to come out with all these portals and figure out how you would solve each of these puzzles. But what we're going to do right now is we're going to go to that link that I showed you at the start of the stream. So we're going to go off to, not TechSmith, we're going to go off to the Code Hub. .ie/playgrounds. So from this page, this just explains a little bit about the Swift playgrounds that I've authored for the Code Hub. We have a couple turtle graphics ones with this very cool looking monkey and a turtle. This is a holiday themed one with the Christmas tree and a Santa hat on the monkey. And we've got a text adventure one. We'll have some sessions about each one of these playgrounds as we go on. But what we're going to do right now is get this feed into our playgrounds. So with the subscribe button here, if we hit subscribe, it doesn't cost anything. This is all free. It'll open up Swift Playgrounds for me on the iPad, or it'll crash because I already have it added. And what you'll see is if we close that playground and go down to the See All button for more playgrounds, it's going to show me all the other feeds that I have. So these are all the playgrounds from Apple. And in fact, if you want to get ready for tomorrow's lesson, you might download the Learn to Code 2 playground. We have some augmented reality playgrounds that we'll get into a little bit later in the sessions. We have some starting points, some blank playgrounds for you to play around with on your own. And then we have some of these third-party ones. So I have a Make Block one. I have this Fundamentals of Programming in Swift. That's mine from the Code Hub. And that's what you should see after subscribing to that playground feed. So what we're going to work with is we're going to tap on this one, the Turtle Graphics Simplified. And this is a playground I developed. We're going to get that playground. I developed this playground to kind of show off a Turtle graphics library I wrote that I think is really useful for learning how to code with. So we're going to open this playground up. It's going to ask me, it comes from a third party. Are you sure you want to open it? I'm pretty sure I can trust myself. So I'll say yes, open. Okay. So at the very start, this is very like the Learn to Code playgrounds. We have a bit of text here explaining what's going on and in this playground and how it's designed, and then some of the commands that you can use here. And I've tried to simplify the interface for the turtle as much as possible in this playground. So it's a bit like an old programming language called Logo. So you can see over here, I've got some code. This looks relatively familiar. There's some extra stuff. There's some sort of text in yellow. There's cool little color swabs that if you tap on them, it'll bring up a color chooser. But if I run this code, and there's a fair chunk of it, if I run this code, the monkey will go off, because it's not a turtle anymore, it's a monkey. We'll go off and we'll run this code here that draws my octagon. And then afterwards it'll change the pen size, move a little bit, and then we have kind of a for loop here. So 45 times we're going to set the color to some random color, go forward 30, right 90, forward 5, right 85, and then forward 28. And we come up with this mess over here. I personally like this almost as much as the Learn to Code playgrounds, because you can go and play around with this as much as you like and start to explore loops and see what happens when you let the computer do something a bunch of times and just change small variables along the way. So let's tap in here, and we're actually going to add a for loop. So we've just learned about for loops, so we can use like a real for loop and not that turtle repeat command. So let's do something 10 times. 10 times we're going to go forward, and then I can tap on this forward distance here, and it's going to ask me for a number. So let's have it go forward maybe 40. And then I'll tap to the end here, just after the parentheses, and I'll hit the return key down here. And now I want it to make this interesting. I could run this now, and it'll just go forward 40 steps 10 times, which means I'm drawing way off screen somewhere over here. You can see I have a helpful degree helper here that'll show me what 360 degrees will turn me, 45, 90, 180 if I turn right. So let's do that. Let's say, all right, I want to go right so many degrees. Let's go 45 degrees and see what happens. There's my octagon. Okay, cool. And there's my... All right, here's my new 10-sided thing. Oh, but it's not 10-sided. That's because maybe my angle's off. So maybe I have to play around with this. This is great when we're doing geometry lessons in school, because this really helps you feel how a triangle is constructed, how a circle is constructed. all these different sided shapes. So when you download this playground, it's worth playing around with your for loops and using these simple commands here: forward, right. We do have a function called random color, so you can set your color to random color. You can also see that if you want, you could call set color. And if we tap on this guy, we can choose down here in the autocomplete bar either random color or this little block. So if we tap on that little block, we've now got a color picker. So we can pick orange. Now it doesn't make a lot of sense to set the color every single time to the same color, so let's change that to random color. So there's my first shape. Here's my second one. Not cool, with random colors, not bad. And then here's my 45-sided creation. So this is just another place for you to play around with your for loops. If you want to play around with this and you think that you get stuck and you're getting lots of red dots like this, and you're kind of confused, and everything seems like it's unfixable, you can always go up to these three dots and choose reset page, and you'll get it back to the original state. So you'll have your all your different shapes there. Now the other thing you could do is say, actually, do you know what? I think I don't like any of that. I'm going to select all and just delete it all. That's fine too. When you run your code, you're just going to have your cool monkey sitting there in the middle waiting for you to do something. So this is a fun playground to play around with. That's all we're going to get into today in terms of that playground. But it's a great place to practice your for loops. And you'll see later, we've got a couple other challenges in here. We ask you to write your name, draw a flag. We picked the Irish flag because it's a lot easier than the American flag. You might see a use for loops in there, or just how to draw letters and what the geometry of a letter looks like. So for now, what we're going to do is we're going to go back and we're going to look at what we're going to cover tomorrow, because all of a sudden things get deadly serious tomorrow. So in books, we've been in our for loops. We've covered all of this stuff. We've solved nearly every puzzle in that chapter. We talk about dancing. Chapter 4 in Everyone Can Code Puzzles is a bit of a departure from the Learn to Code 1 playground. Now we're going to get into much more abstract concepts, and these are going to be as tough as the previous stuff is. This is possibly even tougher to understand. So we'll take our time and we'll walk through this a few different ways. You can see that what we're going to need is Learn to Code 2, the Spirals Playground, and Answers. We'll walk through getting all of that stuff next time. But before we get into any coding next time, what I'd like you to do on your iPad is grab an app that I developed to help introduce variables to you. So it's called Learning Variables. I'm going to post the link on the website later today. If you go to the App Store here, we're going to go to the App Store. We're going to go to search down here, and I'm going to type in learning variables, and it should come up as an autocomplete there. We'll tap on it. Now it's not this reading eggs, it's this one over here. You can see the Code Hub logo. So if we tap on that, we'll see that it's an iPad application. It also runs on your phone. It runs on your Mac. A couple screenshots. I want you to download this. It's free. If you need your parents to use their fingerprint to download it for you, I'd encourage you to get that done this evening or tomorrow before the next coding session, because we're going to be walking through this a little bit to learn a little bit more about variables, and I hope that'll help set us up well for Chapter 4 of Everyone Can Code Puzzles. All right, that's it for today. We'll see you tomorrow, 1 p.m. Irish time. Thanks.